Hello and welcome to this special edition of the Network Collector Short Take. Today I am on location in Boston, the fine folks here at 128 Technology. And today we're going to dig in and find out exactly how they managed to build a software-defined WAN without tunnels or overlays, I guess officially. So settle in as we're about to hear some significant innovation in the SD-WAN market. So today I'm joined by Ritesh and Eric, who are both VPs of product management here at 128 Technologies. Thanks for joining me today.
Thanks for having us.
So before we jump into the deep stuff, why don't you give us the high-level overview of what it is you're doing here at 128?
We make software-based session-oriented routers. The difference between traditional routers and us is we work on sessions. So we keep state per session during the transient flow, and we forward based on that state. The advantage of doing that is we are able to do everything at line rate, but without the use of tunnels or overheads. Multi-site connectivity or WAN, SD-WANs is one of the big features we have, is one of the best use cases we have. Because we don't use tunnels, we have very high scale, very high performance. You don't have to make a full mesh just like you have to do with IPsec tunnels or any other tunnels. In our case, it's an any-to-any connection between sites. And because of this, you're able to have, there's no thromboning of traffic, there's low latency, there's high-speed failovers. All our failovers are always instantaneous because we don't need to make backup tunnels and so on. Because of that, we run on white boxes, which provide a very cost-effective solution for SD-WANs.
And there's a variety of use cases that we address. SD-WAN is a big one. A lot of our customers are interested in, but there are a variety of cloud interconnect or data center, hybrid cloud interconnect data center use cases, as well as security use cases that we encounter as we engage with our customers.
Man, I mean, that's all the words I want to talk about today. Like, you just hit them all at once. So we're going to take them one by one. I think that I got to see you guys at NFT 20 when you guys had a 2-hour presentation. It was like my first introduction to what you were doing. And the thing I think that most surprised me and intrigued me was this idea of tunnelless SD-WAN. And my first question was about, well, how do you get that feature set, right? Because we're used to the idea like, I don't care about the transit, and I can send it over because I have the tunnel and no one in the middle knows what's going on, right? That seems like a value. But you guys were saying, wait a minute, no, there's a better way to do it. And then the other thing is security, right? So one of the things when we think about tunnels traditionally is IPsec provides us some level of obfuscation. So as we transit a middle network, that data isn't seen by the people who are forwarding the traffic. So how do you address those two things, and how are you doing this? Because I think it's really interesting, and I think even a more important question is why. So why do you think that a tunnelless approach is a better approach than what everyone else in the SD-WAN market is doing?
If you look at the current deployments which are there with IPsec VPNs or tunnels, or any sort of overlays or VPNs, the number of tunnels you can create per branch router is pretty limited. So let's say you have thousands of sites, it's impossible to make 1,000 times 1,000 mesh of full IPsec tunnels. It's an n-square problem. You can't do that.
Well, if you go buy lots and lots of hardware, you can. But and I'm sure all the vendors love you if you do that. But that's not necessarily a positive, economic force for your business.
That's true.
Right?
And the other option is you make hub and spoke. Yep. Then you create hub sites, but that makes the design complex. It also requires a lot of configuration, a lot of IP address management, and so on. In our case, it's an any-to-any connection. The reason you need to add a full IP header in IPsec VPNs is because you want to tell which path to go instead of taking the exact path which the original source and destination was. In our case, we don't need to do that because we are session-based. So the routers keep state and forward based on that state. And we don't need to encapsulate packets, and we don't need to add this other IPsec, or not IPsec, but IPsec VPN GRE header, a full IP header plus some GRE bits and so on. We don't have to do that. And that saves bandwidth in the network. It creates high scale. Just to give you a comparison, a traditional branch router would do about maybe 1,000 tunnels or so on. In our case, we can do about 5 million flows. So it's not just slightly improvement in scale, it's like 1,000x improvement in scale. And also, the point you mentioned that we need to obfuscate the traffic so that no one else in the middle can see it. So we have FIPS 140-2 certification. We can encrypt flows, we can authenticate flows. And also what we do is when we send the packets out, we NAT them. So we double NAT them so that any network in the middle or any router in the middle has no knowledge of the original IP packets or the original IP header, just like IPsec VPNs do. In IPsec VPNs, actually, you can see the inner header. In our case, you don't even have that because it's NATed. So there's high scale, high performance. And regarding security, you spoke about it just now. We are like a firewall. We are a deny by default router. So unlike a traditional router where you set things up and then you put ACLs to block traffic, we do the opposite in the sense, just like firewalls, you create rules, and based on those rules, we forward traffic. We have ICSA certification from Verizon, and so we are a full layer 2 to layer 4 firewall in the network today.
Okay.
I was just going to add to some degree, when I think of the solution, it's almost more like a firewall than a router in that it's very stateful.
That's a scary statement to me.
Right?
There's a lot of people out there like, I haven't liked routing on firewalls, but let's
but it's interesting because I think it helps people relate to it, because when you ask the question of how can you get by without having encapsulation, and the answer is if you maintain state, you can, and you have a lot more flexibility. And just to add to what Ritesh was saying, a lot of our customers actually want more visibility, and to some degree what's happened is people are using an IPsec tunnel for kind of multiple purposes it wasn't really intended for.
Oh, absolutely true.
And we're starting to separate that, right? So we can encrypt if you need to encrypt, but we don't force you to stick all those sessions into a tunnel that's going one place. I mean, on its face, if you were to redesign it today, I don't think you would have designed it with an IPsec tunnel to solve these same problems.
Okay, that makes sense. But you have the ability to encrypt the payload without adding an additional headers around the outside. Is that correct?
That's correct. We only add, for authentication, we'll add the authentication header.
Sure.
HMAC shard.
Right, but we're not taking an IP packet, fully encapsulating it with a new header, and all the other stuff that goes around it. We're not wrapping the packet. We're taking that payload, encrypting that. And then when you say it's session-based, I remember this was also one of those interesting points from NFT20. It's like, took me a minute to get my head wrapped around that, and I'm sure our listeners are going to have the same thing. You're using like the destination port, correct, on the destination router to keep track of which flow belongs to which in devices. So really, you initiate that flow or that session on the first traffic that goes across, and then from there on out, the originating router sends to that same destination port on the destination router, so the destination router knows what the actual destination is supposed to be. So even though you don't have the original IP and the destination IP, all that other information, it knows what it is and it reassembles it based off of that first. So there's a little bit of overhead on that first packet rather than overhead happening on every single packet. Is that correct?
Yeah, that's right. That's absolutely right. So in the first packet, we do an in-band signaling, and we send a metadata which tells the destination router how to NAT the packet back and send it out. We also have some other control information in that header, like QoS settings and other things which you do for some innovative signaling between the routers. But you're right that the source router picks a destination port and destination IP address based off the far end router and NATs it to that address. Thereby, we eliminate the need for having any encapsulation or any other information in the packet. But in the first packet, there is metadata to tell the other side how to NAT it back. And after that, there is no overhead in the packet at all.
So, I mean, the use case that I see in this, that I've done voice work in my previous life, lots of little itty-bitty packets that all get encapsulated in a big header. And when you start sending voice with IPsec encapsulation, like, the overhead starts escalating really, really rapidly. Absolutely. And then when I hear about this solution, I'm like, okay, well, yeah, that first packet has some overhead, but everything after that doesn't.
That's correct.
Right. And so and that's a really impressive solution. I do want to move on though, because I think we have a lot to talk about, and there's just a lot of interesting things. So I've heard a term thrown around, and I want to understand it, and it's secure vector routing. What does that mean? It's a term that I think is unique to your product. And so what do you mean when you guys talk about secure vector routing?
Well, when we talk about vectors, the way in which we're thinking of a vector, we always think in terms of these sessions. The sessions are initiated from a client toward an application. That's the directionality of that session. The session is made up of multiple flows going toward the application and back from the application, but the direction is who initiated it in. So when we talk about vectors, we're talking about that directional vector, and that becomes very important from a security perspective. So you expect in certain applications outsiders to access a database inside your data center. You don't expect someone inside the data center to be relaying a bunch of data from that database out, a breach of some sort. So directionality becomes something that's very important when you start to think about the security of the solutions and the systems that you're starting to deploy.
So that's built in, as in you can identify policies and ways you expect your traffic to flow, and you're going to key off those anomalies. And like that's going to start alerting people that things are going on that shouldn't be going on.
Well, or they're not even allowed.
Not even allowed.
Not even allowed. So in our data model, there's a concept of tenants or of consumers of services, and then services, the applications that are there. So you can indicate where tenants are, where services are, and if there's not that direction available, a tenant starting from a data center where the database is going out, will never allow traffic to go that direction. So with that deny by default, combined with directionality and vectors means that you have a secure framework that is very sound.
That's
Does that make sense?
It does. It absolutely does. It's actually something I didn't get from the NFT 20 presentation. So I'm really glad we talked about that. And I guess it goes without saying, but I think we need to say it, right? There's a controller that manages all of this, right? Like just like other solutions, there's got to be something in the middle that's kind of managing the intelligence of this distributed network. Can you talk a little bit about how that works?
Sure.
So it's not more like a controller, but it's like an orchestrator in the sense it tells everybody what to do and distributes policies and lets everybody know what to do, but it doesn't participate in any routing decisions or any routing flows. So there's no thromboning of traffic, or it doesn't wait for any routing decision to come through for the routers to forward traffic. The routers independently monitor all paths, select sessions based on the paths and so on. But it does require the orchestrator to tell it what those sessions are, where they are located, where the new services are. And it's very dynamic in the sense you can add, remove, modify services on the fly. So you could say, there's a service, use that first in my data center. When it gets loaded, I could spin up an Elasticsearch in Amazon and I could load balance to it and so on. So the orchestrator is basically telling everybody who's located where and what the services need. For example, what kind of QoS, security, or the settings they need.
Mapping. That sounds like a previous technology that we've done before, but no, I mean, so the idea is it's gonna keep track of what is where, and so you have some flexibility. You no longer have services tied to IPs, which is, I guess, one of the big things with software-defined networking in all areas, whether you're talking about WAN or you're talking about the access or data center. The idea is like, let's stop using the IP for like where stuff actually is or how to do security. So that makes sense.
Well, and one of the things I think that we think is important, everybody demands a single pane of glass to manage lots of routers in an SD-WAN use case. One of the areas where architecturally we're often a little bit different is that our data model creates global policies. So many people essentially with that front end will sort of effectuate policy, but they'll create custom policies on a per router basis as opposed to having it all in one data model. And we have a uniform data model because we architected from day one that way, which allows you to create security policies, service policies that can be uniform throughout your entire network or authority in our parlance.
Yeah, I mean, that's an important point. I mean, I don't think that's unique. I
Sure.
mean, like that's where the whole industry is heading, but it
Sure.
is super critical. Like as things get more complex, I mean, it's so funny because we talk about, we're going to simplify things, we're going to abstract things. This is one of my soapboxes, guys. Like it's not getting simpler. All we're doing is we're enabling more complex policy, but because we do that, managing essentially is just absolutely essential. So you have to have that ability to distribute that. You brought up cloud just a moment ago, and I want to talk about that because I think a lot of the, a lot of the people in the SD-WAN space are starting to talk about how they're enabling cloud connectivity and how they're, you're bringing additional value to the ideas infrastructure as a service and trying to make that less about, I just have my point-to-point connection here and more about flexibility and where we can have workloads and things like that. Are you guys doing anything inside the cloud that is enabling your customers to do creative things?
Absolutely. So for many of the SD-WAN use cases, there's a bunch of branches, but a lot of them are now going into the cloud because what's happened is an application that used to be in the data center is now being migrated to the cloud. So you have to connect to the cloud appropriately from all your branches. There's a number of benefits that are related to not using tunnels going into the cloud. I mean, you illustrated one just in terms of overhead, but there's many others because oftentimes IPsec tunnels tend to have natural limitations in terms of termination and cloud points. That's an area where, as we've integrated with other customers, they often have challenges in getting data throughput into the cloud, and they have to use either many tunnels from different points, or it's just hard to scale. And that's an advantage that we have in being able to send any session anywhere. So we've seen that particularly in the cloud use cases. But perhaps the biggest impediment that people run into in the cloud tends to be security. They're just worried about shifting from a private data center that they owned everything to something that's in the cloud where they don't own anything per se. It's partially just a mentality thing. But this is where having a software-based solution, so you can have the same solution in your private data center inside the cloud, having global policies where they can be consistent in all these different locations, doing it high performance with secure vector routing, and then making it reliable. Because the other thing that is logical for the cloud use case that comes from SD-WAN is if you move all your applications from local to in the cloud, if you lose connectivity to the cloud, you can't do anything. I mean, it's really obvious,
the logic,
right?
Yeah.
I mean, it's not rocket science, but multipath routing is really important for the cloud, right?
It really is.
And also how you pay the cloud service providers, in the sense the public cloud service providers, they charge you based on the size of the instance you're going to use and how much data you're going to send back and forth from them.
No, how much data you're going to send out.
Send
They'll take
out.
as much data. They'll take as much data as you'll send.
Yeah.
But if you want it back,
But if you remove the overhead, you automatically save because on the bandwidth, so you have to pay 30% less, let's say.
That's a really good point. There is an economic discussion here from an overhead perspective, depending on the size of packets and the type of data you're sending. I think most people are bulk, so the overhead's a smaller amount. But man, if you were sending small packets, man, there's going to be a big difference in that cost.
Well, and to your point, like you don't realize it day one when you pick Amazon, but when you decide to switch to Azure, that's a different story,
it's a really
man.
expensive proposition. Absolutely.
Yes.
Well, guys, thanks so much for coming on today. You're doing some really innovative things. It was great to talk about what you're doing here at 128 Technology. If you all want to learn more, you can go to 128technology.com. We're going to be doing a fun thing tomorrow. That's why we're up here, actually, there is a Networking Field Day exclusive event here at 128 Technology. So we're going to be doing a whole day deep dive. So if this was just enough to whet the appetite, you can get all the information you possibly ever want from Networking Field Day exclusive tomorrow. I'm going to set up a short link to that. It's going to be tnc.li/128tech. That was a lot of letters and numbers and stuff, so I'll make sure to put that in show notes and on the site and everything. But if you had a pen and paper, you're perfect. So you can go there and watch all the videos from when we record tomorrow. So thanks for watching, thanks for listening, and we'll see you next time.